question the exercise, or should we
Yeah,
cover? Yeah. Okay. I mean, today we're going to work on. Okay. Today we're going to look at missing values, and one of the main points in the chapter, other than a few like helper functions that help you deal with NA or fill in missing data, they try to make was between explicitly missing values and implicitly missing values. And so explicit means that there's actually either you have some other indicator or an NA in your data that shows this measurement of whatever this piece of data is missing. And so the exercise focuses on trying to determine missing values, implicitly missing values. And so let me just open the exercise book. Where is it? Am I looking? I am looking at the wrong thing. 1 second. Here we go. And I'm going to share my screen in a second when I have this ready. Okay, can people see that? My screen? Yeah, okay, great. Can I make this a little bit larger? Why is this not working? Okay, apparently I don't know how to operate my computer today. Okay, so the exercise asks, can you find any relationship between the carrier and the rows that appear to be missing from lanes? And so here in the previous section, they look at the NYC flights 13 from 2013 data set. And one way to find implicit meaning data is often that you have different data sets. And by joining them, you can find data that's missing in the other one. And so the join, and we're going to talk more about joins next week, but the join that's very suitable for it is an anti-join, which basically looks at one data set and looks for all the things, one data set X, and looks for any rows that are in X but are not in Y. I hope I got that right, but I think that's correct, right? Yeah. Okay, good. And so to go about this, let's see. Yeah. Okay. We need the library, so we get the NYC flights data set and the what is the other one? The tidyverse. I'm just gonna load. And joins are in dplyr, is that correct? I think they're all in dplyr. So I just run those two code, those two lines. And so now we have, I think, the planes data. Let's just look at the planes. Planes. I'll run this. Let me just call it here, then it opens in the view. Planes. Oh no, why is this not working? Okay, so this is the planes data set. And so each plane has a tail number and manufacturer and all this information that are specific to the plane. So the tail number is kind of the identifier of the plane. And then we have another data set, which is called the flights data, which are the different recorded flights with departure time. We have calculated a bunch of time. So let's also look at this. Okay, and so here you see we have like when the flight happens, the departure time, the schedule time, and so on. And we don't really care about that, but one of the shared variables we find is the tail number. And so now we basically want to know, okay, which tail numbers are in this data set that are actually not represented in the planes data set. That's the question we're trying to answer. And so I'm just gonna, so to do this, we take the flights data. Oh, misspelled that. Okay. Flights data, type this into, I'm just gonna select the two things we're actually interested in. So that would be the tail number. And what else do we need from this? Just the tail number? I think so,
I
right?
thought yeah, just the tail number. I thought there was something about carrier too. I thought I was looking at the relationship of carrier.
Yeah, but the carrier, oh, the carrier. Yeah, exactly. And carrier. You're correct. Because that's what we actually want to figure out. So carrier, thank you. Okay, and then now we want to know which flights are recorded, or which planes with the tail number are recorded in the flights data set, but are actually not recorded in the planes data set. So like I said, that's the anti-join. So we get only the rows that are in flights, but that are not in the planes. And planes. And then we do, I'm going to be explicit. So by, and then join by. And we learn more about that in the next chapter. But basically, the first argument, this argument is which is the other data set that we're joining to. And then the by indicates which identifier do we use to join the two data sets. And so we're gonna join by a tail number. And after this, let's just look at this. Why don't we just look at that output? So we get now a long list of the tail number and carrier. And so now we're curious, is and those are all the planes, and those are all the tail numbers that are in the flight set, but not in the plane set. And now we basically want to know, okay, which one of the carrier is most represented? So we can just use a function that's called count to count which ones are missing. And what we want to count is the carriers. So we do the carrier. And then, spelled that, carrier. And then we want it to be sorted, because then we see which ones are the most represented. So sort is true. So basic, okay. Oh, okay. And so if I run this, now we get this data set, and then we get all those counts. And I'm realizing maybe we want only distinct. So right now it counts each tail number again and again. So I want actually just distinct tail numbers. Distinct tail number and carrier. And now we know there's 430 planes missing from the American Airlines, and then NQ, I forgot what it stands for, but if you now look at the planes data set, and I have this stupid annotate thing in the way, I'm sorry about that. But if you look at the data set, then it reports here plane metadata for all plane tail numbers found in the FAA aircraft registry, and then most important, American Airways, AA, and Envoy Air and Q report fleet numbers rather than tail numbers, so can't be matched. Don't really understand what that means, but it says explicitly they cannot be matched. So it's not a surprise that those carriers, the tail numbers that correspond to American Airlines and what is the other one, Envoy Air, are the most missing ones. And I mean, there's a couple of other ones, but percentage-wise of the other tail numbers is really a small fraction. Who knows what's going on? But that explains why we see those the most. And that is the exercise. I know this was very short, but I thought that was very interesting. Yeah. And I don't know, Colin, what do you think? Should we maybe, you said you had a few things you wanted to point out that struck you in the chapter that might be worth sharing?
Yeah, no, I think just a little bit like talking about like the exercise, like I think this was I also I didn't go about it the same way. But I like the use of distinct and count. I think that was kind of an interesting thing. Well, using the anti-join to first identify which values were actually missing from those two tables. And then the distinct, the discount was interesting first. The one thing that I didn't like about like the book was and I guess maybe the question what did focus us on carrier focus us on carrier and tail number. But the one thing that I wish the book had in the chapter was focused on like how do you even just identify if NAs are if NAs are present in your columns. Like I know
Oh
we
yeah,
talked a little bit about it earlier, but it would have been great if there was like a refresher to be like, hey, here's some really quick ways to just like identify if there are NAs. And so that was the first thing that I had a question was just like, okay, which columns have NAs missing in these tables? And so that was like my first question to get answered. But I just wanted to pose it to the group a little bit about like if anybody has any quick ways to do that. I have one way that I've used quite a bit, but I was wondering if
yeah,
there's anybody who has any tips about like how can you quickly say you have like a table with 15, 20 different columns and you don't know which columns are missing, what would you do?
yeah. I think we talked about this in previous videos. So the skimr package has a function called skim, and it gives you some general statistics. I don't know if I have it installed here. Let me just check. Then we can just check it out. Library skimr. No, okay. Let me just quickly install it. I should have it cached, so it shouldn't take too long. Skimr. Okay. Well, he says it's cached and then it takes forever. Okay, anyway, it gives you some statistics like depending on what kind of data type each column is, you get different statistics. So if it's a factor, for example, it gives you the counts of the different levels, for example. For numerical data, it gives you the mean and the quartiles, I think. Okay, but now it's installed. Let's just start the skimr package, and then I don't know if I don't know if the flights data has a lot of missing values, but let's see. Skim. Okay. So now you get the different variables and it sorts them, I think. But so it gives you a general summary, like the rows and number of columns, then which columns, data types do you have represented? So character, numeric, and date columns. And yeah, the character gives you all kind of stuff here. And let's see. Oh yeah, and then here in the numeric, for example, you have the number missing. And then you see here, you have, for example, 8,255 missing out of what is the total number of rows? 30, over 300,000 rows. So that gives you kind of an idea which ones are missing. I didn't have enough time to look at it. I'm also aware of a different package called Naniar. Do I still have the thing open? So Naniar is also a package that I've heard of, but I never really used to work a lot with it. But I think it has some helper functions that gives you some reports or even plots you the data. But I haven't played around with that. Anything from your side, Colin or DJ?
Yeah,
I'll let
I mean,
DJ.
I used to use a package called Emily, which like visualize like a missing values in the like entire data set. Like you can visually you can see that like by a bar graph or something like that. So I used in like a recent my project. So it was very helpful for, like visualizing like what percentage of data is missing in the particular data set. So yeah.
Yeah.
And
Yeah,
good evening, everyone.
Hi.
Yeah,
Hi.
I normally use sapply in combination with sum is NA with an anonymous function. So that will give you the total number of NAs on each column as a factor.
That makes a lot of sense too. Yeah. Yeah. Supply.
Apply the data frame, then anonymous function, then sum is NA.
It's NA. Yeah. Yeah.
Oh yeah,
And then,
sum's a good one. Oh, go ahead, Stefan.
no, yeah, and we talked about this with the summary functions, right? Because you can then in dplyr summarize and then do a sum of all the is and a's, which gives you true, false, and then you get the numbers that way. That is also a combination to get at that.
Yeah, I like the sum idea. I mean, I do something similar too, and I'm just passing it in the chat. I lean on using per and is NA and any just to identify to give me a Boolean if there are any missing values in a column. So it would be go through each column, identify if there's any or if there is an NA, and then any just returns one value. So if any of them are true, it would return true. If there are an NA value that's located in it. So yeah, these are all great trips. I'm gonna actually try the sum with this, which I think might give you actually the count of how many missing values that you have. I didn't
So
think about
here,
that before.
yeah, here's your approach where we take the planes and if any are missing. So it shows you that in year there's some missing, and in speed there's some missing. Yeah, cool. Yeah, and then yeah, for example, let's just use the flights data and do summarize and missing. Which one was one of the missing ones? So I can departure time, missing depth. And so that would be the sum of all the is and a's of depth time. This. So if I run this, then I get the number 8,255, just like we got from skimr.
Mm-hmm. And if you take the any, like where I use any, if you replace that with sum, it will give you the count of how many missing you have for each column as well, which I thought was kind of a neat idea too.
How would you write that? Summarize, does it apply across all the columns? Where you probably need to use an across or something, right?
I posted it in the chat. S apply,
Oh.
then it will give you across all the columns.
Okay,
Yep.
that's true.
And then and also too, and like if you in the map function, so like any, if you just replace any with sum as well, it will do the same calculation. Sapply is the base.
Base R.
Yeah, it's from base R. It's
yeah. Okay. I don't have the peaks tidy, but I can also use flights, I guess.
You can just change the data frame.
Flights,
yeah,
okay.
yeah.
Okay. Oh yeah, cool.
That's nice. Mm-hmm.
And sorry, Colin, I didn't fully catch it. The any. So what would I need to change here?
So on line 10, where it just says any, replace that any function with sum.
Oh, I see. Okay, that's it. All right,
Yep.
let's just.
And it will do the same thing as sapply.
Why are you not? Yeah, copy. Oh yeah. Okay. Cool.
That's a neat little trick. I like that too because I didn't think about like actually counting them. So that sapply using sum is kind of nice. And then if you use per as your iteration, that's really nice. I like that. Gonna have to take that from you.
And then the other, we probably could also do this with summarize. I don't know why I'm spelling it with S today. And do across because that also works, right? And then you can do everything. So then it applies it to all the columns. And then I think also need a anonymous function to make this work. Let's see. Did I get everything right? Yeah. Okay. Let's see if I got this right. Yes.
Oh, nice. Okay, that's cool.
So that's using the across. Did we already cover this? Yes. When you want to apply the same like summary function or something across all columns or a subset of columns. So here in the across function, the first argument is a tidy select. So you can use any tidy select stuff to select columns. So tidy select is like also you can use column names and a colon in between, for example, or you can say where numeric is numeric or something like that. So you can only apply to certain data types. And that also can help you to do those summaries.
Yeah, it's really nice. Cool. Those are some really cool different approaches to not only identifying but being able to count for them as well. That's really cool. I like that. There is no solution to this. There is a solution, but I tried to look at the solution guide, but because of the newer version, I don't think they have the answer, but I think we got the answer. It's well documented. It makes sense. So I think we figured it out. So that's good. Cool. Well, thanks, Stefan. I don't want to hijack it from you. So do you have anything else that you want to add?
No, not really. I thought the other things were very interesting. What was the one function called that kind of fills in the previous last? What was the last observation value or whatever it was called? Let me just look it up. Because you often have it in data, right? That you might have like a value, and then someone is filling out an Excel sheet, and everything stays the same, so they just leave it empty. And so there was a function in the deployer package to fill that in, and I thought that was just like really interesting approach. Yeah, tidyr fill was the function, and it used the last observation carried forward was the LOCF, I think it was called. Maybe I should just share my screen again so we can explicitly look at it here. So there's this, you often have like Derek Whitmore, and then all the next rows are supposed to be for Derek Whitmore. And so you can imagine someone filling out an Excel sheet exactly this way. And so it has missing values, and then you can just use the fill everything function to fill it in. I thought that sounded like very convenient, and yeah, I definitely have encountered that, and I hope everyone will remember like that way to carry forward an observation. I think that's really helpful. That stuck out to me because I never used this function before.
Yeah, I've used it. Tan shared it with me a long time ago because I was dealing with a problem similar to like a time series thing where it would be like you would have like year, quarter, and then a quantitative metric associated with the year and quarter. But the problem is that the quarter would be filled out, but the year wouldn't, and so I would have to fill. And so that it has saved, like fill has been very helpful in some cases, especially with time series stuff that we've worked with in the past, which is great. I'm trying to think of what else. There was one thing that the implicit stuff was interesting, trying to identify, the, implicit missing stuff. I liked the idea about the pivoting wider, but my only concern about that is like, what if you had like a very large data set? Like you could pivot. This is such a small enough data set that you could pivot it. It's only like 2 years and 4 quarters. But what if you had, I mean, I guess you could do like our strategy that we did before is like you could pivot it. You would have a significant amount of columns and then just do like a map DF or like a whatever, and then try and identify if there's any missing. But that was like my only thing about like the pivot wider suggestion to find implicits, which I guess depends on your data that you have available to you.
Yeah.
Go ahead,
I thought the approach with using complete almost a little bit better because you're explicit. So maybe I share my screen again to show this part of the chapter. So here with the complete function, you can basically ask it to complete values for you, and it kind of deduces it, I think, based on other values. And then what I didn't know is you can even add like values that are not in the data set at all. I thought that was interesting here. So for example, in this year, in the data set, there's only 2020 and 2021. But then you can, when you use the complete function, actually give a other range of values. I thought that was also really interesting. I don't know, I cannot think of top of my head application, but often you have these things where you want these missing implicitly missing values, and having this way to add them is really convenient. And yeah, and then now having worked through this chapter, just being aware, I know, oh, I just look in the NA chapter in the R4 data science book is always good.
A good example use case of this that I've seen this used before is in like survey data, and say you have some like longitudinal survey data, and some years you don't ask the question. And so what you can do is you could have a missing. So like if you skipped a question a year, or it's only asked every 2 years, but you want to create some trend visualization of some type, or at least have that data, or at least have like an explicit like NA in there. Complete is helpful in that case because you at least have those years listed and it's NA. And then you could in your note or something indicate like questions only asked, every 2 years, questions only asked, or question was missed in 2021, no data reported or anything like that. But then the statement with like the full sequence part of it, I was kind of looking at that a little bit more. Was that just saying like to create the series, or was that saying like how it actually created? Because that was my question, like what does it use? So like in the example with like the stocks, complete year equals 2019, 2021, comma quarter, I understand that you're explicitly doing the range for year, but then with quarter, is it just looking at the column and then like creating like some factor and saying like this is the grouping of stuff and then creating it? So I didn't understand this line so much about talking about the full sequence, or if that was like, this is another way that you could create a manual sequence. I don't know.
I think that was an extra step. If the range of the variable correct, but not all values are present. Oh, so the complete helps you to kind of add basically at the ends even, so extend, while the full sequence allows you to add values that are missing in between too. So I think the complete probably would also work instead of the full seq is my assumption, because it would, I mean, this here is a, what do you call that when you have a range of values? So it generates a vector, right, of all the values with the in-between values anyway. So I think that has a similar effect. But here the full seq just allows you to basically fill in missing ones. So I wonder if even in this case, like let's say it would for if you have in between missing ones, if you also use this approach and just give the range with the end and beginning and end, then you might have the exact same thing as the full seq, but I'm not sure. It's hard to predict.
Yeah. Interesting.
And the other thing that I actually was not aware of, what is the factors and empty groups, that I thought was really interesting, that you can basically, if you don't have something represented in the data, there's actually these dot drop, which is usually true. And I didn't realize that that's why you don't see it in your summaries or whatever you're doing. And that you can then just do the drop false to actually get the count of 0. That also seems to be very valuable. And that's also true for ggplot. I had no idea. Like that seemed also be very helpful, again, to have those implicitly missing things to actually get a count of 0 to have it in a graph or whatever. That was also pretty neat. All neat little tricks.
Yeah, and that drop was for like ggplot. Those were with like the scale x continuous scale. Well, no, it would just be discrete, right? It wouldn't be with any continuous. Okay, that makes sense.
Yeah.
Okay,
Sorry,
interesting.
I stopped sharing, but it was for the discrete scale. Yeah.
Okay, cool. Yeah, I always forget that you can use that to identify like implicit values, or at least show those implicit missing values for your visualization. So
I would do like a hack where I'm adding a row to add something like that, like the 0 or something, and it's like not as robust, right, than just having the drop. Like, yeah.
I think that's pretty much everything else that I had that I found. I mean, it was a pretty straightforward chapter.
It was very short too.
There was just a couple things that I was like, oh, it's very short. So I guess we could probably give each other time back, because joins is going to be a little bit longer, and I think it has some more exercises in it. I think. Let me just check to make sure. DJ, you can confirm or deny if are there any exercises in here? Oh yeah, there are. Okay, so there's more exercises in here, so we'll definitely be able to spend some more time kind of talking about those next time and picking those apart because I'm sure because joins are always one of those fun topics that gets a little more nuanced sometimes. And I think the expansion of some of the tooling around like the joins that they have now for the tidyverse and the dplyr, there's some more nuance that they built in from the past, which I'm excited to learn more about. Cool. All right, well, I guess if nobody else has anything else, I think we'll give everybody 25 minutes back of their day. And other than that, we'll see everybody next week to talk about joins.
Okay, awesome. Thank you.
All right,
Awesome.
see you, everybody.
Yeah.
Okay, bye bye. Yeah.